Welcome students to Six Sigma Green Belt class, lesson number 14. If you look at the table of contents, we are still talking about the origins of Six Sigma. And today we'll talk about Dr. Walter Shewhart, and if you know, he was very famous for his control charts, and we'll discuss that in detail a little bit. So what I've done is, in this slide, I've given you reference material just in case you do want to go back and review what we discussed in this lecture. Slide 2, which is this one. Going back to slide number 2, Dr. Shewhart, his education was, he had bachelor's of science and master's of science from University of Illinois, and then he had PhD in physics from University of California. His achievements and his recognition under awards, to name a few, he had a Holly Medal from ASME, and then honorary fellowship of the Royal Statistical Society, and then the last one, the Shewhart Medal, is awarded in his honor. He came up with certain things which we'll talk about in detail. These are some of the books that he published. To name a few, number 1, published a series of articles in Bell Systems Technical Journal when he was working there. The second one, Economic Control of Quality of Manufactured Product. And third one, Statistical Method from Viewpoint of Quality Control. So these are few of his published books. And the quote that's listed here and the abstract, we're going to cover that in detail in slide number 3. And slide 3, which is this one, are both reference materials for you to review if you need to do so. So this is still abstract here, and then we'll talk about his cycle later on. So moving on to next slide, talking about his famous quote. Actually, I don't like this color. So we'll go to white. His quote discussion, what he mainly meant was the requirements for accuracy and precision have been pushed gradually further and further by both pure and applied science. So this is a little bit a discussion about his quote. Adding to this and talking about the accuracy and precision that has been gradually pushed in both pure and applied science, and specifically in mass production this is even more, and I'll quote that, exacting. Than compared to pure science in some areas of accuracy and precision. So this basically discusses in detail his quote that you saw on the slide. Now we'll move on to abstract. Dr. Shewhart, he worked at Western Electric Company and that was from 1918 to 1924. And what Western Electric Company, they were basically a manufacturer of hardware for the famous Bell telephone. During the time period when he was working, a lot of opportunities existed to reduce the frequency of failure and repairs. And this was when he was working for Western Electric Company. He had a lot of opportunities to fix or to reduce the frequency of failures and repairs. So, because of this issue, he introduced back in 1924 concept of assignable cause versus the chance cause. Also, to distinguish between the two causes, he introduced control charts, and we'll talk about that later on in this Six Sigma course a little bit more in detail. Shewhart, Dr. Shewhart, he stated that to manage a process economically, it is imperative to bring the production process, or whatever the process is, in statistical state of control. And the reason behind that was so that only variation a company sees is a chance cause. For now, that's all you need to know about this, but we'll talk about this in detail. Shewhart, he helped Bell Telephone Company to make them better in quality, since their foundation in 1925. After working there for a long time, he then retired in 1956. Let me erase that. So he retired in 1956, and what happened was the control charts that he introduced were later on adopted by ASTM in 1933. Those charts were way too famous. Also, his control charts were used to improve production in the form of American War Standard and they were given these zones. Z1.1, Z1.2, and Z1.3. And this was all done during World War II. Dr. Deming, if you remember, we talked about him in previous lecture. He mastered Dr. Shewhart's and Dr. Deming mastered Dr. Schuchart's methods and worked as a consultant for the Japanese industry from 1958 to 1990. And this here we're talking about Dr. Deming. Moving forward, Dr. Shewhart's control charts are even famous today. What the control charts do is they basically monitor a process. So if a process falls outside the defined parameters, we need to react. To bring the process back in acceptable range. The other beauty of his control charts is that his charts helps to identify limits of random variation. So that's the beauty of his control charts. Also, his charts showed when to leave the process alone and when to react. A fellow by the name of Colsar stated that Dr. Deming presented the following methodology for product life cycle in 1951. So the three things of this methodology, they are: number one is to design the product, and establish test parameters and conduct testing. Number two, he said, was make the product which includes the prototype and make the product also in production using production lines, equipment, or machinery. And then once you're doing that, you can do pilot runs to satisfy the production part of it, and the number of sample size you can determine. Minimum sample size is 30 pieces, but you can determine what's the appropriate sample size to do a pilot run to make the product in production. Number three, he said, was bring the product in the market. There are two more points that we need to mention about this. And number four is we test the product in the market and get feedback. And this falls under market research. Number five, based on the feedback that we receive, if needed, redesign the product and continue the cycle. So these were the 5 items that Colsar presented for a product life cycle based on this concept the Japanese introduced a problem-solving methodology known as PDCA. And basically what P stands for is plan, and in this case you decide what is needed what kind of data is needed, and based on that, D is basically do. What that is, whatever you planned, you implement / execute. The planning stage. The check, which is the C, is basically you're trying to put a measurement system in place so that you can check through the measurement system you have in place how you are performing. And the last one, number 4, which is A, act, is based on the results from the check stage. You react accordingly. And the main thing is to always delight the customer. That's the main goal, bottom line. We'll talk about PDCA, which is Plan, Do, Study, Act, and PDCA, which is Plan, Do, Check, Act, later on during the course in more detail. But for now, that's all we need to know. Thank you for participating. Have a wonderful day.